The 5x and 2x here look pretty bogus, right? But you know what? This is actually a really easy problem to solve without L'Hopital's rule. What I did was the following here. So just hang on, guys, because it looks tough here. I first separated the original fraction I gave you. It's just easier to work with. And then I'm multiplying everything by 5x over 5x, and then 2x over 2x. So by adding these terms, I now have more to play with where I can actually rearrange the fractions so that anything that has an x in it looks like the same on the top and bottom. And what's cool here is, first of all, I can look and see that 5x over 2x simplifies to 5 halves. And then secondly, I'm just going to go ahead and break this up as separate limits, right? Now, the 5 halves is just simply that because the limit of 5 halves is just 5 halves here. And then for sine of 5x over 5x, check it out. It looks a lot like this other limit that you may have already learned, right? So how do we take this limit and apply it to the one that looks more complicated here? Well, you can just let a variable u equal 5x. So this becomes a limit as u approaches 0 of sine of u over u, because when x approaches 0, 5x would go to 0, and so would u, right? It doesn't change the limit. So this is all equaling 1. But then for this other limit here with tangent on the bottom, maybe you've seen this other limit where tangent of x is on the top. But why don't you just take the reciprocal of this? Flip the fraction, you still get a 1, right? You can still apply the same u substitution here and try it for yourself above. And if you want to actually prove this limit, by the way, tell me in the comments how you would do it. Think about how this tangent of x equals sine of x over cosine of x. So with all of that being said, we're just going to end up with 1 times 5 halves.